Hello, you're welcome to our mathematics class. And in mathematics, we shall be looking at this broad topic called trigonometry. Now, in trigonometry, we shall be solving questions under the sine, cosine, tangent, elevation, depression, bearing, and identities. So, this class is going to be a continuation. We need to set the basis, that is, the short explanation to solving the long questions that we have. All right, so we shall be looking at those headings that we set. All right, so we'll start first with a triangle. Now, here is a right angle triangle that has A, B, and C as the edges. Now, this A has a side which is opposite it, so we have a small a there, and then this capital C has a small c, and then this capital B has a b, small b, at this other side. Now from here we have this angle, hence this part where the angle is facing is called the opposite. All right, so here we have our opposite, and over here the longest side of a right angle triangle represents the hypotenuse, and then this other side represents the adjacent. Now from here we need to talk about what the Pythagoras theorem is. Pythagoras theorem or rule, and it says that a squared equal to b squared plus c squared. That is, hypotenuse squared equal to opposite squared plus adjacent squared. So this is what we use to solve questions that relate to Pythagoras theorem. Next is SOHCAHTOA, which is so important in solving questions that have to do with triangles. Now, what does that SOHCAHTOA mean? We have that sine theta, so let's take this as theta. Sine theta, which is the angle at B, is equal to opposite all over hypotenuse. Now, where O is the opposite and H is the hypotenuse, all right? Or we could also take it that opposite is B and then the hypotenuse is A. Then for cos B, that's as this same B, equal to adjacent over hypotenuse, where adjacent is C and hypotenuse is A. And next we have tan B, that's tan angle at B, which is theta, equal to opposite over adjacent. Opposite over adjacent. And when we look here, our opposite is B, that's small b, and the adjacent is this small c over here. Alright, so next we look at general angles, which is formed by the four quadrants. Now when we talk about the four quadrants, we have a y-axis and then we have a x-axis. Here is the first quadrant, and then we have the second quadrant, third and fourth quadrant. There's a general rule of angles that we have over here. Now if you have an angle that proceeds in this direction, that is coming from here over to this place, now normally the angles when they move in this direction, which is an anti-clockwise direction, it is termed positive, right? So this is positive. But when the angle proceeds in this other direction, we have negative. Next is that when we take this angle here, this is a right angle triangle now, and we have to look at the angle here. Let's say that this angle here is 45 degrees. We can take the sine, the cos, and the tan of this angle. And so when we consider it carefully, we have that in this first quadrant, when we take this place as x and this as y, when we decide to take sine of this angle, okay, let's take this as the h. Now if I take the sine of 45, we'll realize that the sine of 45 degree here is going to give us a positive angle. And so in this first quadrant, we have that sine theta, which is the angle here, is going to be a positive one. Then the cos theta, that is cos 45 of this angle here, is also a positive. And then tan theta of this first angle is also positive. So we have positive all through. in the first quadrant, and so because of that we have it as A. A means that all of the sine, cos and tan are positive. When we move on to the second quadrant and we draw a particular angle over here, now let's take that the angle subtends from here down to this side, right? Now at this side we draw a line, and with this line we find that this is the negative x-axis, so this is minus x-axis, and here we have this as still the positive y-axis. Now when we consider the angle made here, now we arrive that at this second quadrant only the sine happen to be positive. So sine theta, the theta is going to be, if for instance everything here is 135, right? So if it is 135 degree, so we have that sine theta is going to be positive, while cos theta and tan theta will happen to be negative at the second quadrant. Next, at the third quadrant, if we decide to have a line like this and we want to take the angle, now in this case, for the angle to have reached there, it means that it had traveled round to this direction, right? So let's take it that this angle, that is this blue line, the angle is 225 degrees. Now with that in mind, this angle that subtends from this positive x-axis over to this place is 225 degrees. We can decide to find the angle which is here. Now if we take the angle here, we find that this angle here is going to be 225 minus 180, so that's 45, right? So we draw a line here, and now we have under 90 degree over here, so this is under 90 degree. And so when we take the cos, sine and tan at the third quadrant, we will find out that sine and cos are both negative, right? Then the tan happens to be positive at this particular side. And next, at the fourth quadrant, now let's say that this line that moved from here over here and then to here has moved over to this place. Now when we draw the line, now meaning that for it to have traveled must have gone all the way around this circle in an anti-clockwise direction. Let's now say that from here down to this place it had gone 315 degrees, right? Now if we take this angle here is going to be 270, that is from here down to this place is 270, right? So 315 minus 270 will give us 45 degree. And so when we take the sine, cos and tan of that, we have only cos to be positive. So we have sine theta is negative, so we have our cos theta to be positive, while tan theta is negative. With all these derivatives, we arrived at the first quadrant, all of them are positive. At the second quadrant, only sine is positive. At the third quadrant, only tan is positive. And at the fourth quadrant, only cos is positive. So we have A, S, T, S, which can sometimes be called acts or casts. Next, the drill to finding angles that fall between the first, second, third and fourth quadrant is that if you have your angle at the first quadrant, let's take it that the angle is 45 degree. So we'll have it that if the angle is 45 degree, so we'll have it that sine 45 degree is equal to plus sine 45 degree. If it is going to be a cos 45 degree is also going to be plus cos 45 degree. If it is going to be a tan 45 degree equals to plus tan 45 degree, since all the entities are positive. But when we proceed to the second quadrant, if theta, the angle we are given, is 135 degrees, so let's take the theta to be 135 degree. Now sine 135 degree is going to be equal to plus sine 180 minus 135 degree. And if you look at this is plus sine 180 minus 135, which is also going to be plus sine 45. But when the theta is 135 at the second quadrant, cos 135 equal to minus cos 180 minus 135 degree. So meaning that cos 135 degree is equal to minus cos 45 degree. Next, for tan, if the theta is 135, tan 35 degree, tan 135 degree equal to minus tan into brackets 180 minus 135 degree. And so this means that tan 135 degree is equal to minus tan 45. Next, at the third quadrant, if our theta happen to be 225, all right, so we have 225 for the third quadrant. So if you have it as 225, we are going to have that sine 225 equal to minus sine 225 minus 180. So that is the drill about the third quadrant. So we are saying that sine 225 equal to minus sine 45, because 225 minus 180 gives 45 degree. All right, then at this, for the cos, we have cos 225 is also equal to minus cos 225 minus 180 degree. And then for tan, if theta is 225, we have it that since tan is positive, we have it that equal to plus tan 225 minus 180 degree. And then if at the fourth quadrant, the angle is 315, that is from here over to this place is 315 degree. So we have it that sine 315 degree is equal to minus sine 360 minus 315. Then for cos 315 is equal to plus cos 360 minus 315. And then tan is going to be tan 315 equal to minus tan 360 minus 315 degree. And so in all this, tan 315 equal to minus tan 45. So all what we've gotten all the way from second quadrant to the fourth quadrant are their corresponding acute angle. And if I mean acute angle, now we have 45, 45, 45. So it is less than 90 degrees. And then next we have a table showing special angles. The angles include 0, 30, 45, 60, 90, 180, 270, and 360. And so we have sine theta, cos theta, tan theta. These special angles are so important because they provide the short form of these angles, and that's what we'll be using to solve some of the questions under trigonometry. All right, so we'll move on to the sine rule. So let's say that we have a triangle like this. This triangle may be an equilateral triangle, may be isosceles, it could be a scaling triangle, all right, in which here we have A, B, and C. The side that is opposite this angle B carries small b, and then this capital C has small c here, and then this capital A has small a here. The sine rule says that A over sine A equal to B over sine B equal to C over sine capital C. So meaning that the angle at A is what we'll be written here. So sine angle at A, and then sine angle at B, and then sine angle at C. Afterwards, we have what we know as the cosine rule. Taking this particular triangle as an instance, we have that this small c, so c squared equal to a squared plus b squared minus 2ab cos angle at c. That's a rule. And so what does this mean? If you are to find this angle, if you are to find this side, and you are given this and this side and this angle here, you'll be able to find it. Or we have a squared equal to c squared plus b squared minus 2cb cos angle at A, and then b square equal to a square plus c square minus 2ac cos angle at B. We could be told to find the area of an angle like this. Normally we know that the area of a triangle is half base times height, where this is base and this is height. That is the area of a triangle. But when we have a case such as this, where we do not have a right angle triangle, right? This is a right angle, but this is not a right angle triangle. We could easily find the area of the triangle by saying that half BC sine A, that is, if we are given BC, we can use half BC sine angle at A, or we could have half CA sine angle at B, or we could have half AB sine angle at C. So these are the different ways we can find the area of this triangle. Alright, so we want to briefly talk about bearing and distances. Now, we have the 4 cardinal points, that is north, south, east, and west. Alright, now with this in mind, the middle of north and east gives northeast, and the middle over here gives southeast. Here we have southwest, and here we have northwest. Take note that north would always come first, then the other side. Likewise over here, the south comes first and then the other side. Alright, so if you are told that there's a body at A and it is 53 degrees, so if you are told that there's a body at A and that we should find the distance of B from A. To find the distance of B from A, and the degree is 53 degrees. Now what we need to do is this: we take our measurements always from the north. So from the north we proceed, if we proceed like this, this is 90 degree. If we proceed, this is another 90 degree, this is another 90 degree, and this is another 90 degree. So 90 plus 90 gives 180 degree. 180 degree plus another 90, that gives 270 degree, and then 270 degree plus another 90, that gives 360 degrees. Now it proceeds in the clockwise direction. So if you are told that a body is 53 degrees centimeter from A, what we'll do is that from A we'll calculate that here is the north of A. Going from here to this direction, let's say it has 53 degrees. So 53 degrees is measured in this form, and then we'll point that this is our location B, from which we'll draw another cardinal point. And so for this, we'll have that this is 53 degrees. So we represent that that B from A equal to 053 degree, or using the north and east side label, that is, we'll say that this is north, right, and this is east. So the middle of north and east is northeast, so we call it north 53 degrees to the east. Now let us consider what we've just said is the distance of B from A, but we can also find the distance of A from B. We are talking about from B, meaning that we are going to take a measurement from B here. Now from B, what we'll do is that we'll start from the north likewise again, and then we'll measure it to where it stops here. So in this case now we are looking for A from B. So we have to measure, this is 90 plus 90, and the angle over here, under angles, this 53 degree equal to 53 degree over here, and the reason is because they are alternate angles. So we have that 90 plus 90 here, which is 180, plus this 53, and that gives 233. So that's 233 degrees. Alright, so we could also be told that the distance of B from A is 127. So when you hear from A, first determine your A. This is the north of A, right? So this point is point A, and we're told it is 127 degrees. Now 127 degrees lies from here to this place. Why? Because this is 90 degree and another 90 degree is up to this place, and when you get to this place you'll be having 180. So meaning that 127 is between this place and this place. Alright, so we have this as our point A, and you draw it to any point. You can call it, this is your point B. And so we have it that B from A equal to 127 degree, or you can call it, this is south and this is east, so you can call it south. All right, so this is now south going towards the east. You know, this is south going towards east. Now what will this angle be? And that was going to be 180 minus 127, and that gives us 53 degrees towards the east. So that's the corresponding angle for this. Then we could also find A from B. Now when we're talking about from B, that means that we will take our angle from B. So how do we do that? We'll go round like this, and then we will stop here. And doing that means that this is 90 plus 90 plus 90, that is 270. And then this small angle here, we need to find the angle there. And how do we find the angle there? Here is how we get it. We have that this place is 53 degree. That means that if this is 53 degree, the angle over here too will be 53 degree. So to find this one is going to be 90 minus 53. Why? Because it is a right angle. That is, the angle there is 90. So we have that 90 minus 53, this will be 37 degree. And so for that, we'll now have that this is 90, 90, 90, that's 270. Then 270 plus 37, that gives 307. And so we have it that 307 degree, that is A from B is this. Next, we could also have B from A. When we're told that B from A is 205, what we need to do is first we draw our cardinal point, B from A. Now let's this be our A from A, and here is the north of A. We're told this is 205 degree. 205 must be lying in this particular, in this third quadrant here. Alright, meaning that we have 90, 90, which is 180, and then when you get to this place, that's 270. But we are not expected to get to 270, so we can stop somewhere along here, and then we'll draw our line. So meaning that this is where B is located. And so if B is located there, what we need to do is we draw a 4 cardinal point for B. And so we have that B from A is this angle here, and we called it 205 degree. It could also be called, now this is south and this is west. What is the degree from here to here? That is from south going towards the west. That's 25 degree. And so because of that, we call it south 25 degree. So like it's going from the south to the west, so we call it south 25 degrees to the west. We could also find A from B. A from B is going to be, now this is B here, so we start always from the north. So north going here, it stops at this particular line. Now what is this angle here? This angle here is equal to this angle because they are alternate angles. And so we'll have it that A from B equal to 25 degrees. Here we have our north, and that means it's going towards the east. So you can call it north 25 degrees to the east. Alright, so when we talk about elevation and depression. Elevation means that there's someone down looking up at an object. The angle of elevation of this particular person is equal to the angle that this line makes with the horizontal. This is what angle of elevation means. Then angle of depression is simply when a person is up and looking at an object that is down. Now, the angle of depression is equal to the angle between this line and the horizontal. And so this is angle of depression. Now do not think that, so if for instance you are given an angle over here and you are told to find the angle of depression. So let's say you are given an angle here as K and you are asked to find the angle of depression. All you need to do is, since the angle, total angle from here to here is 90 degrees, all you do is to say that 90 minus K will give you your theta, which theta is the angle of depression. Next, we'll consider Pythagorean identities. In Pythagorean identities, it's a manipulation of the sine and the cos. We know that sine theta equal to opposite over hypotenuse, and then we have cos theta equal to adjacent over hypotenuse. Alright, then we have our tan theta equal to opposite over adjacent. It is possible for us to combine sine theta and cos theta, and so we have that sine theta over cos theta equal to tan theta. This can be proven if we decide to use this, that is having opposite over hypotenuse divided by adjacent over hypotenuse. We'll end up having this particular one, which is opposite over adjacent, which is tan theta. Next, we have that 1 over sine theta, which is the inverse of sine, equal to cosec theta. And then we have that 1 over cos theta equal to sec theta. We have that 1 over tan theta equal to cot theta. All these are short forms. Cot here means cotangent. Alright? Sec here means secant. And then cosecant. And next, we have that cos theta over sine theta equal to cot theta. Alright? Some other identities include sine square theta plus cos square theta equal to 1. And also tan square theta plus 1 equal to sec square theta. And also that cos square theta plus 1 gives cosec square theta. Now all these are the identities that we need to make use of, especially when we have to solve questions. So we have 1, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We still have some more identities. Next, we have that when we have a circle like this and it subtends an angle, whereby this is a minor sector, right? So we have an angle here which is known as the theta. Now we measure a radian as the angle subtended at the center of a circle by an arc equal in length to the radius. And so the length of this arc being equal to this radius gives us 1 radian. And then we have that 1 degree equal to pi over 180 radian. This is a conversion between degree and the radian, or we may have it that pi radian equal to 180 degrees. We shall surely solve questions that relate to this so that we can understand better. And then we move on to what we know as the compound angles. The important thing about compound angles is their formulas. Now we are told that for all angles of A and B, now let's say the angles we are referring to are A and B, sine A plus B, okay, plus or minus B, equal to sine A cos B plus or minus cos A sine B. Next, we have that cos A plus or minus B equal to cos A cos B plus or minus sine A sine angle at B. Alright, next we have that tan A plus or minus B equal to tan A plus or minus tan B over 1 plus or minus tan A tan B. Sine 2A, so it's more like multiplying the A by 2, like we have A plus A, equal to 2 sine A cos A. And next we have that cos 2A gives us cos squared A minus sine squared A, or 2 cos squared A minus 1, or 1 minus 2 sine squared A. So these are the three formulas you can use to get cos 2A. And lastly, we have that tan 2A equal to 2 tan A divided by 1 minus tan squared A. These are the formulas that we shall use. And so now we proceed to solving questions under trigonometry. Let's solve some questions on trigonometry. Here's the question which says that we should solve the equations A, cos theta equal to sine 40, and B, sine theta equal to cos 2 theta. Now in this question, the first question says cos theta equal to sine 40 degree. What we are expected to find is what is the value of theta at which cos that angle will be equal to sine 40. Now there is a particular rule that says that cos theta equal to sine 90 minus theta, and also that sine theta also equal to cos 90 minus theta. We are not using this, we use this. Why? Because we are interested in this theta. Alright, so we'll have it that since cos theta equal to sine 40 and cos theta is also equal to sine 90 minus theta, what we could do is we could equate this with this, since this and this are the same. So we say that sine 40 degree equal to sine 90 minus theta. Sine cancels sine, so we are left with 40 equal to 90 minus theta. And so theta equal to 90 minus 40, and that gives 50. And so that is the value of theta. Next question says, alright, so the big part says sine theta equal to cos 2 theta. In this case, we are to find the value of theta. And how do we find it? We would make use of this particular one, that is sine theta equal to cos 90 minus theta. And so the brain behind it is the fact that sine theta is sine theta here, so we can equate this with this. And so we'll have that cos 2 theta equal to cos 90 minus theta. Since cos are the same, we'll take that out. And so we have 2 theta equal to 90 minus theta. We collect like terms. So 90 equal to 2 theta plus theta, which gives 3 theta equal to 90. And so theta equal to 90 divided by 3, and so we have 30 degrees. Here's the question which says, the bearing of x from y is 046 degree. What is the bearing of y from x? Right, so we have the bearing of x from y. What we'll do is that since it is from y, we'll take y first. This point shows y, and this is the north of y. Now, since we take our reading from the north always, so we'll read 46 degree in a clockwise direction, and 46 degree is between this line and this line. And next we'll draw a line that goes to x. Alright, so here's our x, and then we draw the 4 cardinal points. So the bearing of x from y is 46 degree. We have to find the bearing of y from x, which goes from north over to this place. From here to this place, we have 90. To this place gives 180. Then 180 plus the angle that is here. 46 equal to x. Why? They are called alternate angles. So with that, we now have that 180 plus 46, and that gives 226 degree. And so bearing of y from x equal to 226 degrees, or you can say this is south going towards the west. You can call it south 46 degrees, because here is also 46 degrees. 46 degrees to the west. Or this is south going towards the west. This angle here is 46, just like this is 46. They are alternate angles, right? So we say south 46 degrees to the west. Here's the next question, and it says calculate AD to the nearest millimeter. Here is the diagram. This diagram is a right angle triangle. We have two of them. Here is the smaller one, which is inside a bigger one, but they share the same base. Now, for what we need to do is to apply Pythagoras theorem. Here is the small triangle. For the small triangle, we have 5 here and we have 4 over here. So what we need to do is to find this side. Now let's take this place as our angle, and so this place is opposite. And so we have that hypotenuse squared equal to opposite squared plus adjacent squared. The hypotenuse over here is 5, so we have 5 squared, and the opposite is x, so we take it as x squared, plus the adjacent is 4, so we have 4 squared. And so next, we can bring this x squared here. Okay, we can leave this x squared here and bring this here. So we have 5 squared minus 4 squared equal to x squared. 5 squared gives 25 minus 4 squared gives 16 equal to x squared. So we have 9 equal to x squared. So value of x equal to square root of 9, which is 3. Then for the bigger triangle, here we have 6 and we have 4. So you have to find the value of here to here, right? We can call this y. We have that y squared equal to 6 squared minus 4 squared. We are still following the same Pythagoras rule. Y squared equal to 6 squared, which is 36, minus 4 squared, which is 16. And so we have 20. So y equal to square root of 20. Next, we have gotten y, that is from here to here, which is root 20. And then we got it from here to here, which is 3. So we need to get this place. And how do we get that? We'll get AD by saying AB minus DB. AB is root 20 minus DB, which is 3. Root 20 gives 4.472 minus 3. Alright, so we'll subtract 3 from 4.472, and that gives 1.472. Alright, in centimeter. We are asked to give our answer to the nearest millimeter. To change from centimeter to millimeter, we multiply by 10, and so we'll arrive at 14.72, which is 15 millimeter. When we approximate it, that is 14.72 approximated will become 15 millimeter. Next question says, if sin theta equal to 5 over 13, find the value of 1 plus tan theta over 1 minus tan theta. Here is a question which is quite simple. We are told that sin theta equal to 5 over 13. What does this mean? This 5 over 13 is gotten from a right angle triangle. We can call this the angle we are looking for, and we can call this theta. And if this is theta, this side is the opposite, and here is the adjacent, and we have the hypotenuse over here. Sine is so, that's opposite over hypotenuse, meaning that this is opposite and this 13 is hypotenuse. So what we could do is to replace this opposite with 5 and replace this hypotenuse with 13, right? If this is 5 and 13, what will this place be? How relevant is that? We will get the relevance from the fact that the question says 1 plus tan theta over 1 minus tan theta. And we know that tan theta equal to 2, that's opposite over adjacent, right? We have our opposite, which is 5, but we do not know what our adjacent is. And so because of that, we need to apply Pythagoras rule or the theorem to find the value of adjacent. And we have that adjacent squared equal to hypotenuse squared minus opposite squared. Hypotenuse is 13 squared minus opposite, which is 5 squared. And so we have 169 minus 25. This gives 144 equal to adjacent squared. Hence, A equal to the square root of 144, 144, that gives 12. So with this analysis, our adjacent is 12. So we place 12 in this place. Next, we can now substitute by saying that tan theta equal to opposite is 5 and adjacent is 12. Next, we'll bring 1 plus tan theta. Since our tan theta is 5 over 12, we'll say that 1 plus 5 over 12. Now we'll find the LCM of this, and we have 1 in 12 is 12, 12 times 1 is 12, plus 12 in 12 is 1, 1 times 5 is 5. So we have 17 over 12 over here, and then 1 minus tan theta, which is 1 over 1 minus tan theta is 5 over 2. So we place 5 over 2 over 5 over 12. So from here we find the LCM of this, which is 12. 1 in 12 is 12. 12 times 1 is 12 minus 5. So we have 7 over 12 here. Next, this means this one is 1 plus tan theta divided by this. So we have 17 over 12 divided by 7 over 12, which is equal to 17 over 12 multiplied by 12 over 7. That is, when this divided change to times, the 12 at the denominator here will move up, while the 7 at the numerator will move down. And it applies only to the fraction or the number which is after the division. 12 cancel 12, and we're having 17 over 7. 7 into 17, that's 2. That's 2 times 7 is 14. And then 17 minus 14, that gives 3 over 7. And so we have succeeded in solving this question, which is 1 plus tan theta over 1 minus tan theta. Next question says tan A is 61 km north and 23 km east of tan B. Calculate the bearing of A from B to the nearest 0.1 degree. Now in this question, we're told that we have to take our bearing from town B. So let's take this as our town B and take a cardinal point at town B. Here is the north, here is west, and here is south. Here is east. We're told that town A is 61 km to the north. That does not mean that it is exactly at that 61 km to the north, but here is what we have. So we are saying that town A is around this side, right? Then it now goes 23 km to the east, meaning we will go in this direction. So we will arrive that this is town A. Then we will join this. Here is 61 km, and here we have 23 km. So in this question, we are told that we should find the bearing of A from B. This is A from B. What we have to find is the angle here, that is A from B, moving from north, moving towards the east, right? From north towards the east. Now to find this angle here, we will apply SOHCAHTOA because we want to find the angle. When we look at it closely, if this is the angle, this is the opposite, and here we have the adjacent. This is the longest side, meaning this is the hypotenuse. Applying SOHCAHTOA, which of the sine, cos, and tan involves the values we've been given? We have 61 as the adjacent, and we have 23 as the opposite. And so we are dealing with opposite and adjacent, which is tan theta. So tan theta equal to the opposite over adjacent. And in this question, opposite is 23 and adjacent is 61. 23 divided by 61, that gives 0.3770. That is tan theta equal to 0.3770. Then theta equal to arc of tan 0.3770. This is called arc of tan or inverse of tan. So when we find the arc of tan 0.3770, we will arrive at 20.66 degree approximately as the theta. And now we are asked to find our answer to the nearest 0.1 degree. Alright, meaning that this is to the nearest 1 decimal place. And so we approximate this and we have 20.7 degree as the value of. So we are having now that the bearing of A from B equal to 020.7 degree, or not 20.70 degree east. Here's the next question, and it says find the positive angle between 0 degree and 360 degree, which is equivalent to A, 610 degree, B, minus 60 degree, C, minus 150 degree, and D, 720 degree. For the first one, we have 610 degree. When we take a look at the 4 cardinal points, here north, alright, and here we have the first quadrant, here is the second, here is the third, and here is the fourth. Alright, so when we take our reading that is going in an anti-clockwise direction, when we go once like this, that shows we've gone 360 degrees, right? And apart from being 360 degrees, going in this direction is a positive direction. But if we went the other direction, that's the negative direction. But in this case, we have more than 360 degrees. We are expected to have gone 360 degrees once, and then we proceed again. So what we need to do is to have it at 610 minus 360 degrees. We have 0, 5, 2. So if we've gone once 350 degrees, we still need to go for another 250 degrees. And going 250 degrees requires knowing which quadrant we are going to arrive at. The positive angle is 250 degrees. Here is the answer. There are times when we will be asked to give the acute angle of this particular 610 degrees. Yes, we have arrived at the fact that 610 degrees is equivalent to 250 degrees. But to find its equivalent acute angle, we need to find the exact location where this 250 degrees stops. And this is what I mean. Since it's a 250 degree, we'll go 90 degree, making 180, and before we get to 270, we'll stop somewhere around here, right? So meaning that it is stopping at the third quadrant. This is first, second, third. And if you remember in our explanation, we gave a rule that theta at the third quadrant equal to theta minus 180. That's at the third quadrant. So if we want to put a sign here, we will say that sine theta equal to sine theta minus 250 at the third quadrant. And so for this, our theta is 250. So place 250 equal to 250 minus 180. And that would give 70 degree. Hence, this is the equivalent acute angle of 250 degree and 610 degree. The B part says minus 60 degree, and here is the 4 cardinal points. Here we have our first quadrant, second, third, and fourth. For us to have a minus 60 degree, it means that instead of it proceeding in an anti-clockwise direction to give a positive sign, we had to proceed in the negative direction, which is in this part. So if we had proceeded in this part, that means that it stopped somewhere around here. So this is a minus 60 degrees. So meaning that this is 60 degrees in the negative direction. And so what we need to do is that to get its equivalent positive angle, what we need to do is to add 360 to it. And so we'll have minus 60 degree plus 360 degree. Hence, that gives 300 degree. And so the equivalent positive angle of minus 60 degree is 300 degree. Next, we could be asked to find its equivalent acute angle. When we now have a positive 300 degree, this 300 degree falls in which quadrant if we decide to proceed in the anti-clockwise direction, which is a positive direction. If we proceed like this, we will cover 90 degree, 180 degree, to 70 degree, and we will stop somewhere at the fourth quadrant. And at the fourth quadrant, we have a rule that theta equal to 360 degree minus theta. Hence, if theta is 300, that will be 360 minus 300 degree, and that will be 300 equal to 60 degree. Now, what does this mean? We are saying that cos 300 degree equals to cos 60 degree at this point. But if you are dealing with sine and tan, we will have it that sine 300 degree equal to minus sine 60 degree. And if you are dealing with tan, it will be tan 300 degree equal to minus tan 60 degree. If you come back to this gave us 70 degree, right? And so what we can arrive at here is that since it stopped at the third quadrant, we will have it that tan 250 degree equal to tan 70 degree, or sine 250 degree equal to minus sine 70 degree, or cos 250 degree equal to minus cos 70 degree. That is what all this means. The C part says minus 150 degrees. We have to find its equivalent angle between 0 and 360 degrees. When we have our four cardinal points, here we have the first, second, third, and fourth. A negative 150 degree means that this did not proceed in this direction where it is meant to follow, which is the positive. Rather, it went the opposite. Now, going the opposite means that it had gone more than 90 degree, right? This is 90 degree, and stopped somewhere here. So we have a minus 150 degree all through to this place. Its equivalent positive angle between 0 and 360 will be to add 360 degree to it. And so we have minus 150 degree plus 360 degree, and that will give 210 degree. That is the answer. But if you are told to find its equivalent acute angle, since this is 210 degree, which is stopping at the third quadrant, we have a rule that says that our theta at the third quadrant equal to the theta minus 180 degree. In this case, the theta is 210, and that's equal to 210 minus 180 degree, and that produces 30 degree. So we are saying 210 degree equal to 30 degree. Now when we attach sine, cos, and tan, at the third quadrant, our tan is positive, and so we have that tan 210 equal to tan 30 degree. Likewise, sine 210 equal to minus sine 30 degree, and finally that cos 210 equal to minus cos 30 degree. D, we have 760 degree. And then in our four cardinal points, we have that this is a positive 760 degree. That means it proceeded in this direction. It went once. If it goes once, that's 360. So we have 760 minus 360. We arrive at 400. Next, it proceeded another 360 degrees. And so we have 400 minus 360 degree. That's 0, 4. Meaning that its equivalent is 40. When it went round a second time, it stopped here and proceeded by 40 degree and stopped. So here is the angle, meaning that we will stop at 40 degree. With that, we can now say that its equivalent is 40 degree. Now there's no need to find its equivalent acute angle, since 40 degree falls in the first quadrant. So at this particular point, we will have it that sine or cos or tan 760 degree equal to sine 40 degree. That is what it means. Likewise, all this, we could have sine cos 760 tan 760 and the likes. That's cos 40 degree tan 40 degree and that. Now I want to point our attention to something here again. Take note that tan 210 degree, we said it's equal to tan 30 degree. It's also equal to tan minus 150 degree that we're given here. So when you punch your calculator, you will find that they are all equivalent to each other. This is also equal to sine minus 150 degree, or this is also equal to cos minus 150 degree. Next question says, evaluate the following. A. Cos 116 degree. B. Sine 137 degree. C. Tan 251 degree. D. Sine minus 58 degree. E. Tan minus 145 degree. And F. Cos minus 33 degree. For the first one, we have to evaluate cos 116 degree. To evaluate is to find it in the 4-figure table, and we evaluate first by finding its equivalent positive angle if it is not given in positive, and also to find its equivalent acute angle. In the first part, we have cos 116 degree. The 116 degree is a positive angle, but it is not an acute, so we need to make it an equivalent one. When we consider the quadrants, 116 lies in the second quadrant, and in the second quadrant we have a rule that we have cos AS. Only sine is positive, meaning that tan and cos are negative. If that be the case, we would take it that cos 116 degree equal to minus cos 180 minus 116 degree, right? So here is a negative because in this second quadrant cos is negative, and so we have that cos 116 equal to minus cos 180 minus 116, that gives 64 degree. And so looking at the table, cos 64 degree, or using the calculator, that would give 0.4384. We have a negative over here, so that is the answer. B, we're given sine 137 degree. First, we'll have our quadrants. 137 degree falls also in the second quadrant. That's 90, and then before we get to 180 degree. And so in this quadrant, sine is positive, right? This is CAST, meaning that sine 137 degree equal to sine. At the second quadrant, we have a rule of saying 180 minus 137, and so sine 137 degree equal to sine 43 degree. We look at sine 43 degree in our table, and that gives us 0.6820, which is a positive answer. We are given tan 251 degree. In our four quadrants, it's a positive angle, so that means it's proceeded and stopped in the third quadrant, right? So this is 251. At the third quadrant, only tan is positive, and so we'll have it that tan 251 degree equal to plus tan. Now at the third quadrant, we have a rule which is the angle 251 minus 180 degree. 251 minus 180 degree, that gives tan 71, and so we are concluding that tan 251 equal to tan 71 degree. And when we look at the table, we'll find that tan 71 equal to 2.9042. D, we have to find sine minus 58. Sine minus 58 degree. For this, we have our four quadrants, Minus 58 means that it's proceeded in the clockwise direction, which is in this direction. That is a negative. Here is the first, second, third, and fourth quadrant. So it stopped at the fourth quadrant, where we have CAST. Now, for it to stop at this negative side, we need to first find its equivalent positive angle. Its equivalent positive angle is gotten by saying minus 58 plus 360 degree, and that gives us 300, and that gives 302 degree. So first and foremost, we are saying that sine minus 58 degree equal to sine 302 degree. So it is on the in the fourth quadrant, and in this fourth quadrant we have that sine 302 degree equal to minus sine 360 minus 302 degree, because sine is negative, and so we have minus sine 360 minus 302, that gives 58 degree, and so sine 302 degree equal to minus sine 58 degree is also equal to sine minus 58 degree. All right, and so when we look at this sine 58 degree, we will have it as 0.8480, and do not forget that we have a negative, so we place our negative over here. Here's the next one, which is tan minus 145 degree. When we consider our four quadrants, minus 145 had proceeded in this direction and stopped here. Here we have the first, second, third, so it stopped at the third quadrant, and at this third quadrant only tan is positive. First, we need to get its equivalent positive angle, and that is gotten by saying minus 145 degree plus 360 degree, and that produces 215 degree. And so we are saying that tan minus 145 degree equal to tan 215 degree. Next, we need to get its equivalent positive angle, and that is gotten by saying that now this is the third quadrant, and here tan is positive, so we have that tan 215 degree equal to tan 215 minus 180 degree, and that produces tan 215 minus 180, we have 35 degree. So checking the table, tan 35 degree gives 0.7002. In essence, tan 215 degree is equal to plus tan 35 degree, and is also equal to tan minus 145 degree. F, the last part, says cos minus 33 degree. We look for the equivalent on the quadrant. Minus 33 means it proceeded in this direction and it stopped somewhere here, right? So this is 33 degree in the negative direction, and here we have cos as being positive. Now the first thing is to find its equivalent positive angle, which is gotten by saying minus 33 plus 360 degrees, and that gives 327 degree. And so we have that cos minus 33 degree equal to cos 327 degree. Next is to find its equivalent its equivalent acute angle, which is cos 327 degree equal to plus cos 360 minus 327 degree, and that produces plus cos 33 degree. Next is to evaluate it by finding it in the table or with the calculator, and that gives 0.8387. That is on the positive side. Next question says solve the following equations. A, 5 sine theta equal to 3. B, 20 sine theta plus 11 equal to 0. C, 1 equal to 4 sine theta. D, 0 equal to 2 plus 3 sine theta. Alright, so let's take the first one, which is 5 sine theta equal to 3. We proceed by bringing 5 over here, and that gives sine theta equal to 3 divided by 5. 3 divided by 5, that gives us 0.6. So we have sine theta equal to 0.6. We find theta by looking for the inverse of sine 0.6 in our table or with the calculator, and that produces 36.87 degree. That's theta. Since our theta here is a positive angle, which when we draw four quadrants, we have CAST. 37 here is in the first quadrant, right? That's approximately. But sine 36.87, which gave us 0.6, cannot only be positive in the first quadrant. It can also be positive in the second quadrant because this is sine and it is positive here. And so what we will do is that we are going to find the other equivalent angle, which we will say that sine that angle would give 0.6. And here's what we mean. At the second quadrant, we have a rule here that says that an equivalent acute angle equal to 180 minus theta. So if our equivalent acute angle is 36.87, which is this, right? Here it was only approximated, equal to 180 minus theta. Hence, our theta equal to 180 minus 36.87, and that will give 143.13 degree. In one word, we are saying that theta has two angles, that is 36.87 or 143.13 degree. And so if we say that sine 36.87, it will give us the same thing as sine 143.13 degree. All right, and that is going to be 0.6. We have B, which is 20 sine theta plus 11 equal to 0. We have to find the value of theta, which is 20 sine theta equal to minus 11. So we have sine theta equal to minus 11 divided by 20, and that gives minus 0.55. And so we are saying that theta equal to arc of sine minus 0.55, and that's the theta gives us minus 33.37 degree to 2 decimal places. Now we have our theta as minus 33.37 degree, meaning if we consider it in the four quadrants, the theta must have gone in the negative direction, right, to have minus 33.37 degree. So first, we need to consider its equivalent positive angle, which will be minus 33.37 plus 360 degrees, and that will be 326.63 degree, approximately 327 degree. Now we are saying now what we are arriving now at is that sine minus 33.37 degree equal to sine 327 degree, and when we find it, it will give us minus 0.55. Now this minus there is also saying that in this quadrant, in these four quadrants, we have negative, and sine is negative in two quadrants and it's positive in two quadrants. Sine is positive in this first and the second quadrant, but it is negative in the third and in the fourth quadrant. This 327 degree falls in the fourth quadrant. Its equivalent acute angle is going to be sine 360 minus 327, and that is sine 33 degree. All right, and over here it is a negative, don't forget, right? So sine 327 degree equal to minus sine 33 degree. But we are not through, because we need to also find in this third quadrant, sine is negative in this third quadrant. we found the equivalent positive angle here, which is in the fourth, but in the third quadrant we will take it that this 33 degree is theta. So we will have that in the third quadrant it will be 33 degree, which is the equivalent equal to its angle in the third quadrant minus 180 degree. This is the rule in the third quadrant, and so theta will give 180 plus 33 degree, and that will eventually give us 213 degree. And so you can now say that sine 213 degree equal to sine 327 degree. All right, so the next one we have C, which is 1 equal to 4 sine theta. We have to find the value of theta. So we have it that sine theta equal to 1 over 4, which is 0.25 equal to sine theta. Hence, theta equal to arc of sine 0.25, and that gives 14.48 degrees. Now in this case, we have our 4 quadrants. Now our sign here is positive, that's positive 14.48, meaning that it is in this particular quadrant, the first quadrant. But let's take note that theta is not only positive in the first quadrant, it is also positive in the second quadrant. And so its equivalent positive angle will be sine 14.48 equal to sine 180 minus theta, as according to the rule in the second quadrant. Right, so sine cancel sine, we're having 14.48 equal to 180 minus theta, and so theta equal to 180 minus 14.48, and that will give 165.52. Therefore, our theta equal to 14.48 or 165.52. And the last one, which is the D, 0 equal to 2 plus 3 sine theta. 2 will come here, and so we'll have minus 2 equal to 3 sine theta, and so we'll have that sine theta equal to minus 2 over 3, and that will be minus 0.667. Hence, theta equal to arc of sine minus 0.667, and that gives minus 41.836 degree as theta. Alright, so in our 4 quadrants, it means theta is at the negative side, which is minus 41.8 degree. Hence, the equivalent positive angle will be minus 41.8 plus 360, and that will give 318.17 degree. So we have theta could be 318.17 degree. Do not forget that our sine theta equal to minus 0.667. This negative means that it is either at the third quadrant or the fourth, because cos CAST, sine is negative at these two sides. Now with that in mind, the equivalent positive angle of 318 equal to, so we have it that sine 318.17 is also equal to minus sine 41.8 degree. So equal to this according to what we have here. Now at the third quadrant, we will have it that this 41.8, when it is in the third quadrant, we will have it that alpha equal to theta minus 180 degree. Our alpha here, we'll take it as 41.8 equal to theta minus 180, and so our theta here equal to 221.8 degree. And so we have a final answer that our theta could either be 318.2 degree or 221.8 degree.